Okay, second question 6. Apparently, I, as a math teacher, need to learn to number, so it's questions 6 through 10. There are apparently 11 problems. A regression analysis of a company's profits from the amount of money spent on advertising finds an R squared of 72. Now, again, it does matter. Advertising would be X and the profits would be Y. And again, why is it important? You would do your advertising to try to influence the profits. So we have to know which one's X, which one's Y. And we find an R squared is 72%. Explain R squared. So R squared, 72% of the variation in Y is explained by X. Amount spent to advertise. Okay, so that's something you have to memorize, how to do R squared. The variation in Y that is explained by X. Pretty straightforward, but if you don't know how to do that. Now, I don't know if we've done one on explaining the slope. I hope we have one coming up. If not, I'll probably practice that in the video because there's definitely explain the slope, explain the y-intercept on the test. So I either need to add that to this in the future, but we'll just get it in this video. All right, match the following correlations. Now remember, it's always a line. So if I had to pick, this is the strongest line that is positive. So that one's C right there. This one's also positive, maybe not quite as strong. So this one's B. This one, if I put a line to it, it's both positive and negative. So that one really should be the one near 0 because it's both positive and negative, about as strong. So they kind of cancel each other out and get you something near 0. And then this one is negative. So that one is B. Should be pretty straightforward, easy points if you can match those correlations. You just got to play a little bit of the game. All right, which of the graphs show no correlation but a strong association? Well, A. You can look at the number. That really has no correlation, but it is a strong relationship. Remember the difference. Association means, are they related? They are. There's a relationship we see there, but correlation is how it fits to a line, and that one doesn't fit to a line at all. All right? Which ones show a moderate correlation? Now you're specifically looking at the numbers, and these are the cutoff numbers. Anything below 30 is weak, whether negative or positive. So this one would be considered weak, but it doesn't ask for weak. Anything above 75 is strong. So this one's strong, and this one's strong, even though the one's negative. So the only one that's moderate is B. That one has a moderate strength. So that's just knowing those two numbers. Okay? 30 and 75. Okay, so now we've got one where we got to put some data in. I should have had this data typed in, but we'll type it up here as we go. X is weeks. Week. And time. Now, time is usually an explanatory variable. They're both time. So it's the number of weeks that they do training that's the explanatory variable. So it is coming in order. And this is the time that they take to complete some task. I'm going on some memory here. And they're trying to get it under 20 minutes to complete this task. I don't know, some sort of an assembly line or something like that. So which one's the explanatory variable? Well, since they're both time, again, that sometimes is confusing, but the number of weeks on the job, if you just said week, that's correct. Weeks on the job is your X variable. And what's the correlation? Well, the correlation we have to get from the calculator. So you do have to know how to find that correlation. So we add the calculator page. Typing the words menu 614. We put in our week and our time. And our correlation is negative 0.968. So very strong. And that's all correlation is, remember. Correlation is simply R. So if you're asked for correlation, that's it. You want to predict whether or not you're qualified for the raise. Would it be appropriate to use a linear model? Now, we've already talked about this before, but anytime you're asked, is a line appropriate, you have to check the residual plot. So, we're going to add the data and statistics page, put the time here, and the weeks here. And you have to get the line on there. Now, I don't know about you, but I can see a slight curve. So I'm gonna guess that the residuals will be curvy. You can kind of see it kind of curving down. But we'll try menu 462. That gets the line on there, and then menu 472 gets the residuals. And I think there's a curve. Now, if somebody said it's random, I might allow it, but I think what I usually go with the rule, on the left they're above, on the right they're above, and in the middle they're all below. So to me it's a curve. It doesn't need to be a perfect curve. If I had one of these, I'm just going to grab one of these and it pulled down, then I might call that random. Okay? I'm going to undo that. So is it okay to use a linear model? The answer here is no. Residual plot is curved. So we had one of each of those. One where the answer is, yeah, it's okay on the problem number one because the residual plot is random. This one, it's not random, it's curved, so we shouldn't actually do it. You know, if we had to do it, you know, they're supposed to make it by 13 weeks. Well, we can, just for fun, we could do it. We could say the equation is 42.07 minus 1.81 times 13 and see if they're going to make it. And if we use the equation, they're going to make it in under 20 according to this equation. But the equation isn't necessarily accurate because the residual plot isn't random. Does that make sense?
So if it was random, we have to plug it
If
in.
it was random, then we might plug it in, we might continue. But none of the question says to plug it in. So don't plug it in unless they ask. And it could. I mean, we could have a part D. Well, if the equation works, would they make it? Sure. A lot of times, like AP test questions might have 3 parts. They might have 4 parts. The really long one, like question 6, a lot of times has 6 parts. So it could. All right. So here we do get to explain the slope. We'll probably practice one of these anyway. This one is a little bit different. It's something unlike. This to me is kind of like a question 6 on the AP exam. Doing something that you maybe should have knowledge of from prior classes, this class, but not really everything. Okay, here in part A, it says, draw the line of best fit and do it accurately. So I leave this one in there. I don't test on this. So you can be like, rest assured, I don't test on it. But here would be the problem. It's got an equation. It says tread equals 36 minus 0.6 times miles. So if you were to try to graph this thing, don't do this. Everybody just watch this for a minute. 36 would be, you know, if you're like, we're counting by 5s, we'd be at 30. Whoops, I have a little off. 36 would be actually up here. I can't even get it on the board, really. 36 would be somewhere, somewhere up here. Oh, man, I'm just really getting annoyed. And I deleted it.
You got 2 markers out.
Oh, that's why. Thank you. I still didn't undo the thing. All right. This 36 is somewhere way up here. I'm going to pull this down a little bit. All right. 30, 35, 36, right? But here's the problem. Look down here. Is this 0? This would be like 20, right? So the 36 is somewhere off the page. I can't even graph this. I mean, if I use this the typical way we would graph it, we'd put the y-intercept and we go down 0.6 over 1, down 0.6 over 1. If I do that, I don't think I'm going to be in line with this graph because the graph isn't zeroed out. We're not starting down here at 0, 0. So I have to figure out another way to do this. So what I'm going to do is I'm going to use an old school method from algebra and from this class. I'm just going to put in a couple of key points. So for instance, I'm just going to take the number 30 and I'm going to put it in here for miles. So if I take 36 minus 0.6 times 30, what that gets me is it gets me 18. It gets me an ordered pair, 30, comma 18. So I'm going to go 30, 18. And it's pretty near that dot there, right? Approximate. Now I'm going to put another point in. So I'm going to go 36 minus 0.6 times 40. And the reason I'm just using some easy points, numbers with zeros in them are a lot easier to multiply. That times that's 24. 36 minus 24 is 12. So another point I can graph is when I put in 40, I get 12. You can put in whatever you want, but at 40, it's about 12 high, and then I'm going to draw my line. Because a best fit line can be made with 2 points. That is the best fit line. It's not even a question. It's telling us it's the best fit line. I'm just going to use 2 points to draw it. Okay, so your support for part A would be that information. I know I didn't give you much space to put it in. A lot of times I try to get these onto one sheet because it just makes it easier for scanning, uploading, and printing and all that if you can get it on one sheet. Okay? Now, I don't have anything like that on the test, but hopefully that makes sense. And again, it's kind of like a question 6 on the AP exam where how would you do this, when the graph is messed up? And one of the things in statistics, you should always look at the scaling of the graph. Like down here, this is 0, but this isn't 0. This would be 20 because it's counted by 5s. Now, let's pay attention to one more thing. It says explain the slope. Down here on the x variable, it says this is miles in thousands. So this is 30,000 miles. That's going to be key to explaining the slope. And on the test tomorrow, you want to pay attention to that kind of stuff. But our slope is this. So we remember in explaining the slope, it's down 0.6 for 1 in y, and this is x. So our y is the tread depth. So I'm going to put this on another page just because I think it's easier. So this is part B. We predict 0.6 less. There's the negative. Tread depth. That's our y. And this is x. For every... Now here's where you could get it wrong. You got to be careful. If you say 1 more mile, you're not going to get both of the points for that. One more, if you say 1 more thousands of miles, and we don't get caught up in all the grammar in this, I would say, yeah, they got it, that it's thousands of miles. So you could say 1 more thousands of miles, or you could say for every 1,000 more miles. Okay, it is 1 more unit, but the units on the bottom of our graph happen to be in thousands of miles. So we do have to get that thousands of miles in there. And sometimes the only place we can get that is recognizing it in the graph. It might have said it in the wording up here. And this is in millimeters. So if you put that in there, 0.6 less millimeters, that's fine. I usually, if there's a couple things like that, I don't try to make it too tricky. All right, part C. One person traveled 36,000 miles. Now, see, here's where a student should recognize, how can that be 36,000? The graph is like at 50. So If we're using the equation, we're going to put in 36. Okay? Using the graph, calculate the residual for this person's tread. Okay, there's a couple things on here. If I find 36, I try to be as accurate as possible. I think it ends up being this dot. Now, I'd allow for differences. Some students might think it's this dot. Okay? Some students could possibly think it's that dot. I'd give you some leeway on that. But I think it's this very first dot here. So over here, that, if I draw a line across, I think that's maybe 10 or 11 or 12. Okay? So, that's the actual loss in tread depth, 11 millimeters. So now we take our equation. The, what is it, tread depth again? What's Y? Predicted tread. Predicted tread equals 36 minus 0.6 times, and we're going to put in that value. It's 36,000, but we put in 36. And we get 14.4. So now let's remember, try to keep this easy. This is a question dealing with residuals. That's 14.4. E equals y minus y hat. What we got off the graph, the actual height of the dot, the actual height, if I made this, is something like 36, 11. Now, what if somebody says 12? Or what if somebody uses one of these other dots? They use 14 or 15. My recommendation is you circle the one you think it is. And there's a lot of leeway. Even on the AP exam, they give you leeway if there's 2 dots that it could be, or even 3 dots that it could be, because we're more concerned about your work and your concept than anything else. I'm going to go with it being 11. So the actual height is 11. Subtract 14.4. So it's negative 3.4. Now, you might be asked, what does that mean? I don't think it says it in this problem, but it means the tire lost .4 less than predicted.
We have to write that out tomorrow.
Might have to. Something like that. It's not in this question. I'm just giving you that as it's possible. What does a negative residual mean? It had 3.4 less than predicted. If it was a positive residual, it had 3.4 more than predicted, right? Or something like that.
So the graph shows
The graph shows the actual.
or the actual.
The actual. And the equation is always the predicted. So the equation is always y hat.
Okay.
Yep. All right, so then it's got another one. If the residual for a person who traveled 20,000 miles was 3 millimeters, what is the actual? Okay, so now this one again, it's part B, I think. E equals y minus y hat. What was the residual? 3?
Yeah.
Okay, so if that's 3 and they traveled 20, I think. No, I think it's right. No, they traveled 20. Sorry, I'm doing this wrong. Where I went. So let me just restart it. This is 3 equals, we have to plug the 20 in. So 36 minus 0.6 times 20 would predict, this is going to be y hat, it would predict 24. So again, this is E equals y minus y hat. So y minus 24. We add 24. So 27,000 miles actually traveled. Is that right? Or is it the tread depth? That's not right. This is the tread depth, so it should be That's the 24. Oh, it's. I don't think it should be actual miles traveled. I have a typo on this. This should be. What's the actual tread depth? So the actual tread depth should be 27. It's not in miles traveled. I wrote that question incorrectly. Glad we caught that before I finished the video. You know, because that's actually why.
Because if it was actually miles traveled, would it just
It'd be 20.
20?
Yeah, it wasn't meant to be a trick question. You know, so what's the actual miles traveled? 20 or 20,000. Sorry. So anybody who already answered that with 20,000, it's not wasn't intended. It's just sometimes I mess up when I write the question. You get them twisted in your head. So I just had a little bit of a problem. So it was intended to be what's the actual tread depth? The tread depth is 27. Okay, does that make sense?
So we can just keep the answer as 27.
Yes. Let's do one more on here. Just because I want to practice this, let's just say we have an equation. Price is predicted to be 3.4 plus 2.1 times time. I don't know what we're doing, but if we say explain the slope in context. So the slope, again, is the 2.1 over 1. Remember, it's y over x. So price, I'm going to assume that the price is in dollars since we're in the United States. So we predict $2.10 more, since it's positive, for one more, and now I don't know if it's minute or hours or what, for one more minute. Now, what if I had that on there? What if I just had time? You could say for one more unit of time. We don't know what the unit of time is. What is the y-intercept if you had to explain the y-intercept? Remember, the y-intercept is we put in 0. So, we predict. If I put in 0, we predict $3.40 if the number of minutes or units of time, if we didn't have minutes, is 0. And you might be asked on that something like, well, does that make sense? I don't know. I want a little more context. Yeah. But it may or may not make sense depending on the situation.
So if it's like a height one, you just say it doesn't make sense
Because you can't have a height of an object that is 0. Yep. And you had mentioned that sometimes the y-intercept doesn't make sense. But we can go back to the notes where if the house has 0 square feet, the cost of the project could still be $45,000 because maybe it's the lot price of the land. Okay. All right. Good timing.